We'll start the class. So we had completed almost a transient part. Yesterday we had discussed a very special questions, special cases. So now we are moving towards a very important chapter. Means like in a transient only we are going to see something important. Okay. So I'd given you yesterday. I'd given you one questions, I think, or no, there was a no questions. Just wait. Okay. So uh, we discussed the questions yesterday, na Priyanka? That questions, special case questions we had solved. Yeah, today we have to see the RLC network in a transient, damping frequencies and all. What is that? And that is very important, very important. And yeah, so it's very important. Okay. So we'll see that network. Before that, solve one question. Your question is, you need to find the rate of change of voltage across the capacitor T is equals to 0 plus. So you need to find the rate of change of voltage, dV by dt. Rate of change of voltage means dV by dt value at T is equals to 0 plus. You need to find. So the circuit is, this is your resistance. This particular is your capacitor. It's a resistance, it's a capacitor, and the value of a capacitor is given like a plus minus V. Means the value of a capacitor is C, the voltage across the capacitor is plus minus V. And you have a switch which getting closed at T is equals to 0. Okay. And this particular parameter is plus minus 1 volt. So how you will solve this question? So guys, if you will see the switching time at T before 0. So how was the network? Network is like that. Okay. So there was a no connection. No connection means it is not connected. So my VC0 minus is equals to VC0 plus is equals to VC0 will be 0. Okay. At T greater than 0, what is happening? We are getting a circuit, this circuit. Yes, positive, negative, 1. What about plus minus V? Means at an infinite amount of time this will get like this, open. Means 0 current will start flowing. So what will the voltage across VC? Minus 1 plus 0 into R plus VC plus V. So you will get V is equals to 1. So V of infinite you are getting 1. So put the value in the equation. Vc of t is equals to V infinite minus V of infinite minus V of 0 e power minus t by RC. So V of infinite is 1. 1, and that is 0. So 1 minus 1 into e power minus t by RC. So what equation you are getting? What you are getting? 1 minus e power minus t by RC. What will the value of R? R value, if you will see from this capacitor, your circuit is becoming like this now. It will become short circuited. This will be, so you are seeing from the capacitor point of view. So this is the R value is this only. Okay, so your VC of t you are getting 1 minus e power minus t by RC. They had asked the rate of change of the voltage. So find dVC by dt. And if you will differentiate it, what you will get? 1 by RC e power minus t by RC at t is equals to 0 plus. So put the value 0. So you will get 1 by RC. Is this part clear, Priyanka? Priyanka, understood? Prasanna, you understood?
Yes.
Okay. So this was one important question. Okay. Now, so find the rate of change of the voltage across the capacitor. That is done. 1 by RC. Okay. Now you have another question. Another 2 3 question is there. So question is, you need to find di by dt at t is equals to 0 plus. So this is your network. It's getting off at t is equals to 0. This positive negative, it's 100 volt, and this is 20 ohm. This particular, sorry, so, this particular is your inductor 1 millihenry, and you have this particular 1 micro farad, and this is 20 ohm. So you need to find the value of a di by dt at t is equals to 0 plus. So di, where is I current is this is your particular I current. So if you want to get the answer for this, means first draw the circuit at t before the zero position. Before the zero position, my circuit is, this is 20 ohm. So before the zero position, my circuit is simply like this. Inductor will be replaced by the short circuit. I am taking at the steady state, means position minus infinite to 0, and this is my 20 ohm, and the capacitor will be replaced by open circuit. So positive negative 100 volt, this is 20 ohm, this is 20 ohm. So what current will flow in this, because there will be a zero current? So what current will flow? 100 divided by 40, so 2.5 ampere. I of 0 minus, we are getting 2.5 ampere. Okay, no problem. And what is the voltage across this capacitor VC0 minus? So if you are getting a 2.5 ampere or 2.5 ampere, so this, in this 2.5 ampere current is flowing. So 2.5 into 20, 2.5 into 20, you are getting, this is 100 by 40. Okay, to 2.5 into 20, how much voltage you will get? How much voltage you will get? 25 into 2, 50 volt. Okay, that means VC 0 minus, if you will do the calculation, you are getting positive negative 50 volt and minus 50, 0 ampere current is flowing, so plus minus VC 0 minus, VC 0 minus value is 50 volt. We are getting VC 0 minus value is 50 volt. So at t is equals to 0 plus, at t is equals to 0 plus, your circuit is becoming like this. Your circuit is becoming like this, positive negative 100, this is 20 ohm, this particular is your 20 ohm, this is your capacitor. So this is shorted, means this resistor will be redundant and the circuit will become like this because it is shorted. This we shorted, so this, the value of a 20 ohm will be 0 only if we do shorted. But one thing is that there is one inductor, so in that inductor at t is equals to 0 plus we are talking, so the current of the inductor will not change. So the current what we are getting 2.5 ampere, and the voltage here what we are getting, the voltage across the capacitor what we are getting 50 volt. So directly we can, at t is equals to 0 plus, we can make it as a battery source, like at t is equals to 0 plus. So what they had asked in the question, di by dt value. Okay, di by dt value. So okay, now you can do one thing. Here it is a inductor, means this is my inductor, so that's why I am taking as a positive negative voltage, VL voltage. So you need to find this VL voltage. So how can you find this VL voltage? Because we are considering at t is equals to 0 plus, so that's why I had drawn my inductor. I am representing this inductor like this. It's having some potential. Okay, so that's why I am representing like this. Okay, now you need to find the value of a VL. How you will get the value of a VL? You know the current, you know the voltage. So how can you get the value of the current? You know the current value. And this, the voltage across this will be 100 only because it is shorted. So overall voltage it will get here 100, and you have a 2.5 ampere, so means voltage across this is 50 volt. So 100 minus 50, so voltage across VL will be 50. So VL is equals to L di by dt. So the value of a VL you got 50, and L value is 1 millihenry. 1 millihenry, that means 1000. So di by dt at t is equals to 0 plus, we are getting 50,000 di by dt. So we can write di by dt like 50 kilo ampere per second. So what we did, see, you need to find the value of a di by dt at t is equals to 0 plus. So at t is equals to 0 plus, we know the current across the inductor will remain same and the voltage across the capacitor will remain same. So before t is less than 0, we are having a circuit like this. So now, and we are assuming that the circuit has achieved its steady state. Okay, so that's why my inductor I represented as a short circuit and capacitor as the open circuit. And from this we get the value of, by applying the KVL and all, we get the value 2.5 ampere current. So 2.5 multiplied by 20, I am getting the here voltage as a positive negative 50. That voltage will be, if I'll use the KVL and the current across this 20 ohm is 0, so I will get the VC value is, VC 0 minus value is 50, and IL 0 minus value I got 2.5 ampere. Now if I'll draw the circuit at t is equals to 0 plus, we are talking about at the instant of a t is equals to 0 plus, not at t is means like infinite. So that's that means what? It having a inductor can be replaced like this as a current source. Because we are talking at t is equals to 0 plus, we are not going to infinite. Okay, so that's why and at t is equals to 0 plus it will have a current 2.5 ampere. I'm taking some voltage, positive negative voltage, that is VL. Okay, and if you need to find this VL value, because you have to find, the relation VL is equals to L di by dt, and they had asked to find the rate of change of the current at t is equals to 0 plus. So here 100 voltage is connected across this particular sources, this particular resistance, and the inductor. So we know that 2.5 ampere current will flow at t is equals to 0 plus. So voltage across this 20 ohm will be 50 volt only, and the voltage across this will be 50, inductor will be 50. So we know the voltage across the inductor is 50, and this L value is 1 millihenry, 1 millihenry. So divided by 1 millihenry, so 1000 will come, and we'll get di by dt at t is equals to 0 plus, that is 50 kilo ampere per second. Is this clear, Prasanna?
Yes, sir.
Okay, fine. Priyanka, you understood?
Yes, sir.
Okay, that's fine. So yeah, so there is one question, last question. We'll move for RLC network. Question is, you need to find I1, I2 and I3 at t is equals to 0 plus, and you have a circuit. So there is a two capacitor, one inductor and one resistor. So how you will solve this particular circuit? So let me draw first. So it's positive negative 90 volt, that is 4 ohm, that is 2 ohm, and here you have 1 millihenry. This is your switch. This particular, it's 2 microfarad, and this is 1 microfarad. Okay, so at t is equals to 0, the switch is getting closed. So we'll solve this circuit before t is less than 0. So how is my circuit? And I1 is this one, this is your I1, this particular is your I2, and this particular is your I3. So you need to find at t is equals to 0 plus. So first find the value. What value we'll get at t before at t is equals to 0 minus. So before means at t is equals to 0 minus, I am assuming my circuit was reached its steady state condition. So if it is reached its steady state condition, inductor will be replaced by short circuit, that I am taking as a IL value, and it is not connected, so it will be like this. And the capacitor, it also by open circuit, and this particular is by open circuit. So both capacitor will be at open circuit. So you have to make like this. Okay, you have to take this as a VC1 value and this as a VC2 value. Okay, you need to find all the things, means at d is equals to 0 minus. So what will be your IL0 minus? IL0 minus nothing, because no current is going. So 90 divided by 4, so it's coming 90 by 4 is how much? 15 ampere. So we got the IL0 minus, and we know that IL0 minus will be equal to IL0 plus, it will be equal to IL of 0. So if you know the value of a 15, and this is oh sorry, 15 by 6 no, 15 by 6 to 4 and 2. So 15 divided by 6 you will get 90 divided by 6 you will get 50 ampere. So 90 divided by 6 you are getting 15 ampere. So this is 4 ohm, this is 2 ohm, so you will get 15 ampere only. Because here it's a 2 ohm resistor, so 90 divided by 6 you are getting a 15 ampere, and you know that IL0 minus equals to IL0 plus is equal to IL0. Okay, you get the value of a 15 ampere, so that means I having a 15 ampere current flowing in this particular circuit. So what will be the voltage across this particular branch? V is equals to 15 into 2, 30 volt. So 30 volt is coming. And now you need to find the value of a VC1 and VC2. So you need to apply, you have a 2 capacitor. Okay, although it is open, so but you have to find the separately. So and we got the value, that is 30 volt, and it is 1 microfarad and it is 2 microfarad. Apply the voltage divider rule and get the value. This is positive negative VC1 and this is positive negative VC2. So VC1 value will be 30 into, in a capacitor we need to multiply it with 2 divided by 3, so we'll get 10. So VC1 value is 20 volt and VC2 value it is 30 into opposite branch. We need to find the value of, but resistor same branch we are doing voltage divider rule, but for capacitor opposite branch. 30 into 1 divided by 2 plus 1, 3, so we'll get 10. So this will be 10 volt. So guys, what you know very means IL0 minus you got, that is 15 ampere. VC1 0 minus you got, that is 20 volt, and VC2 0 minus you got, that is 10 volt. So it will be equal to VC2 0 plus, it will be equal to VC1 0 plus, and this will be equal to IL 0 plus. Now if my at t is equals to 0, my circuit is becoming like this. Okay, I'm considering at t is equals to 0 plus. Okay, that's why I will not ignore the inductor and capacitor. I will not ignore, because we cannot apply the equations, because here we having a various capacitor, various inductor, so we cannot. So that's why I am making positive negative, I am taking it as a VL which having a value, because I am considering this circuit at t is equals to 0 plus. So the value of the inductor current will be same only, that is 15 ampere, and this is getting like this shorted, and I am considering this positive negative voltage we are got at t is equals to 0 plus. That's why I am representing this circuit is representing at t is equals to 0 plus. That's why I am representing 1 microfarad as a voltage source. What voltage we got? 20 volt upside, so 20 volt, and downside what voltage we got? Positive negative 10 volt, and this is your positive negative 90. This is 4 ohm, this is 2 ohm. So guys, now you need to find the value of I1. This I1 you need to find, I2 and I3. So you can easily find, it's not a very big deal. You can easily find this thing. How you can find? See, this particular see, overall voltage will be 20 plus 10, because it is shorted, so 20 plus 10. If you are assuming this as a V parameter, so overall voltage how much you will get? V minus V, I am taking reference, minus V plus 20 plus 10 is equals to 0. So V value is 30. So that is 30. So 90 minus 30, 90 minus 30, I1 value, if I want to find I1 value, will be 90 minus 30 divided by 4. So 60 by 4. So 60 by 4 will be 15 ampere. So 15 ampere current is flowing from this, and this is 20. So the voltage across this particular is 20 only. So 20 divided by 2, 20 divided by 2, you are getting this branch current is 20 divided by 2, 10 ampere. So if 15 ampere is coming and 10 ampere is going downside, so what current will come here? 5 ampere current. Okay, and if you so what about this current 10 ampere? It is 15 ampere to 10 ampere, 15 ampere, so that means 5 ampere current will flow from here. So that's why 5 plus 10, it will give you 15 ampere current. Okay, so 5 plus 10, it will give you 15 ampere current. But you need to find the value of I3. I3 will be this 5 ampere, and all the 5 ampere is going. So that means 5 minus 5, here current will be 0. So this particular thing is representing your I3. So I3 is equals to 0. I1 is equals to 15 ampere and I2 is equals to 5 ampere. So you got the value. I1 is equals to 15 ampere, I2 is equals to 5 ampere, and I3 is equals to 0 ampere. At what time? At t is equals to 0 plus. Is this clear to everyone? Prasanna understood? Priyanka understood?
Yes, sir.
Understood? Priyanka?
Yes, sir.
Okay. So that's good then. Now we are moving to the next topic, that is series RLC network. Okay. Series RLC circuit analyzing. So be careful, because we have to see these things in a control system also. Same concept will come. If you have a circuit like this, RLC. So if you have a circuit like this, RLC, and suppose the current is flowing, I current is flowing. Okay, that I current is flowing. This is R, this is L, this is C. So if you will draw this circuit, what you will get if you will apply the KVL? IR plus voltage across the inductor is how much? L di by dt. L di by dt plus voltage across the capacitor is 1 by C I dt. It is equals to 0. Okay. Now what I am saying, okay guys, so this okay, V is equals to L di by dt. So what you will do now, if you want to get the, so this is your v is equals to L di by dt, right? Right, v is equals to L di by dt, and I is equals to C dv by dt, right? I is equals to C dv by dt. So if you know these things, so you can do the calculations. How you can do the calculations, I will tell you. Yes. Okay. Hmm. Yes, guys. So this circuit, now this same circuit can be represented like this: L d square I y dt square plus R di by dt plus I by C. What I did, I had differentiated. I differentiated this. I differentiate this circuit again with respect to t. So if I'll differentiate this circuit again, then my L di by dt will become L d square I by dt square. I will become di by dt, and this integration of I dt, if I'll differentiate the integration, so the value will come. So I will get the I by C value. Right? Is this clear? So it is equals to 0, and the differentiation of a 0 is 0. Okay. Now yeah. Now you need to know one thing: conversion. Conversion from this to S domain.
So can you repeat that equation once again?
See, this equation, this first equation you understood.
Yeah, that I got it.
So what I am doing, this is my IR plus L di by dt plus 1 by C integrations of I dt is equals to 0. So if I differentiate this equation with respect to dt and this with respect to dt, both side, so what I will get? R di by dt plus L d square I by dt.
square I by dt plus.
Okay. And the differentiation of this integration I dt, so I will come out. That's it. So I is getting so I by C is coming. This integration will get over, and you will get here that
Zero.
0 only. Understood?
Yeah.
So now what we do now? We do conversion. Always remember, di by dt can be means if initial condition is 0, so the Laplace transform of differentiation will be S if initial condition is 0, and the Laplace transform of a d square I by dt square will be S square. Okay, S square. So this is one important point. The Laplace transform, this is transform. Okay, this is transform. So Laplace transform of a differentiation will be S, and the Laplace transform of a integration, is 1 by S. Laplace transform of differentiation is S. Okay, these things you need to remember, and we will see the formula in control system also. Okay, for now just remember. And here the thing is that our initial condition is 0, so that's why we are putting like this. Okay, Actually, the Laplace transform of di by dt will come as a si of s minus I of 0, but we are not taking this part because we are considering our initial condition is 0. These things I will teach you after some time only. So just remember here only, di by dt, the Laplace transform will be s, and di square by dt square is s square. Okay, so what you will get in the Laplace transform, if I will do the Laplace transform, so I will get r s I of s plus L s square I of s. Di by dt, that's why I of s is coming. I of s will become. And okay, and this will be I of s by c is equals to 0. We did the Laplace transform. Now take I of s common and make it as a 0. So you will get rs plus ls square plus 1 by c is equals to 0. So s square, take L common, s square plus rs by L plus L by c is equals to 0. We have took the L common, I of s common. So we are getting the final equations s square plus r by L s plus L by c. This is your final equation. This is your characteristics equation also. Up to here it is understood or any doubt? The Laplace transform of d by dt, remember, s. When initial condition will be 0. I will teach you for the initial condition that it will be different. Some value will come. And the Laplace transform of in signal system also will study these things. And the Laplace transform of integration, if the integration function is there, if any integration function will be there, dt, so 1 by s. Okay, and d square function is there, d square by dt square, so it will be s square. So what I did, r di by dt can be written as rs I of s. L d square I by dt square can be written as L s square I of s, because these are the components, so this will remain like that only. RLC will remain like that only, but your I will be converted into I of s, capital I of s. If voltage was there, so capital V will be converted into capital V of s. Okay, so rs I of s plus ls square I of s plus I of s by c. So everywhere I of s is there, so I of s will be taken common. It will be divided by 0, divided by that, and I took L common, so I am getting one standard form, s square plus r by L s plus L by c. Okay, so if you will find, if you want to find the root of this equation, what you will get? If you want to find the root of this equation, how you will get the root? Discriminant. I hope you remember discriminant. So for finding the root, we do s is equals to minus b plus minus root under b
B
square
square minus 4ac by 2a.
by 2a. So your s value will come how much? Minus b is
Minus r by L.
minus r by L, plus minus root under b square is r by L the whole
R by
square, minus 4 ac. A is 1,
L s by c.
L by c, divided by 2a, divided by 2. So what you are getting, s is equals to minus r by 2l plus minus root under r by, I am writing it like this, r by 2l the whole square minus L by c. If it will go inside the root, it will become 4. So that's why it's a 2a square, and 4 will get cancelled out. So these things I hope you guys clear up to here. Is it clear? Priyanka, is this clear up to here?
Yes, sir.
So this function, this can be written as alpha function, and this can be written as beta function. Okay. this can be written as beta function and this can be written as alpha function. So guys, can anyone tell me when we will get the imaginary value? You know the concept of overdamp, underdamp, critical damp?
Yes,
Overdamped,
sir.
underdamped, and critically damped. What is the condition for overdamped? When zeta is greater than 1.
Greater than 1.
When zeta is less than 1, underdamped. And when zeta is equal to 1, it is critical damp. This condition you know. So actually s square, we got the equation s square plus r by l s plus l by c is equals to 0. In control system, we having the same equation like this, s square plus 2 zeta omega ns plus omega n the whole square. Okay, in control system we'll see this thing, s square plus 2 zeta omega ns plus omega n the whole square. Okay, so can anyone tell me what is my 2 zeta omega n? R by L, from here to here if you'll see. And what is my omega n? Root under L by C. So if you will put the value, what zeta value you will get? R by L by 2, R by 2L into divided by omega n. So zeta value is coming how much? R by 2L, R by 2L, and omega n value, that will be root under C by L. Root under L by C we are getting omega n value, and that is 2 zeta omega n. So root under, so R by 2L. So we are getting this value, right? Right, guys? Is this clear up to here? Priyanka, understood?
Yes, sir.
How we are getting this
Yes.
value, you understood?
Yes.
So means this is your zeta value. Okay, we'll see these things in a control system in a very deep. Okay, so now if you will come to this parameter, this equation, what we got, the equation of s is equals to minus r by 2l plus minus root under r by 2l the whole square minus l by c. So what I want to say you, when you will get this term as a 0, this term as a 0, when it is possible, when r by 2l the whole square will be equal to l by c, right? Will be equal to L by C. Is this clear? Then this term will be 0. When this term will be imaginary, my second term, I am talking about the second term. When this term will be imaginary, when r by 2l value, r, this is a square, okay, this is square, r by 2l the whole square value is lesser than L by C, I will get imaginary value, because the term will come in negative and the root of negative, it will give you the imaginary value. And when it will come positive, when r by 2l the whole square value is greater than L by C, is greater than L by C. So guys, when this parameter is equal, this is known as a critical damp. Critical damp. When you will get the imaginary function, then it will be under damped. Under damped. And when you will get the function like this, r by 2l whole square is greater than l by c, and it is over damped. Is this clear? Prasanna, is this clear?
Got it, sir.
Got it? See, or you can do like this also for finding the over damped, under damped. You can use this standard equation, s square plus 2 zeta omega n s plus omega n the whole square, and you are getting the RLC circuit network, s square plus r by l s plus l by c is equals to 0. So from here you are getting omega n value is root under l by c, and 2 zeta omega n value is r by l. Okay, and when you will put the zeta value r by 2l, and this is omega n, so omega n is coming root under l, so you are getting root under c by l. So particularly you are getting the equation like this, zeta equation you are getting like this, r by 2l root under c by l. When you are substituting this value, and this value, if this particular value is coming equal to 1, it means critical damp. If it is greater than 1, if it is greater than 1, if it is coming, then it is over damped, and if it is coming less than 1, then it is under damped. So you can find by this way also, or by this way also. It's up to you. So I hope you got this particular terminology, because it is very important. That's why I am again and again I'm telling you these things. Prasanna understood? Priyanka understood this RLC network? Okay, now you have the same thing. If we'll go for a parallel RLC network, if we'll go for a parallel RLC circuit, you have L, you have R, you have C. This I am taking as a positive negative V. So this is I am taking as a positive negative V, means this is V. So if I am taking the current I1, if I am taking current I2, if I am current taking I3, so I1 plus I2 plus I3 is equals to 0, right? So value of I1 will be V by R. Value of I2, V is equals to L di by dt. So value of I will be V by L dV. Integration means 1 by L V dV. I value from here. So 1 by L integration V. Sorry, it will be dt only. No? This is dt. Because okay. So we are getting the equation V is equals to L di by dt. So V by L will come and dt will go that side and integrate both sides. So you will get the current in this branch. So you are getting the current 1 by L V dt plus equation of a current for a capacitor is I is equals to current for a capacitor is equals to C dV by dt. So guys, it is equals to 0. Now if you want to make it in the form of a Laplace, Laplace, this will be V of S by R. This 1 by L, this will be V of S by S. Integration can be represented by 1 by S, and this can be represented if you don't want to do that differentiation. By doing that differentiation, you will get S square like that. But I am doing directly because I know the result of an integration. It will come 1 by S, and this V will become capital V of S, and this C will be C only, and dv by dt. So it will be S is equals to 0. So if you will solve this circuit, V of S, here V of S will also be there, V of S. So V of S will gone because it is equated to 0. So we'll take the common and we'll get a result like this: 1 by R plus 1 by Ls plus C S is equals to 0. Take the LCM and solve the equation. You will get if you will take the LCM, you will get RLS plus R plus LC S square is equals to 0. RLS, it will go, if it will go that side, it will become 0. Now take the LC common. If you will take, or I had missed something, let's just let me check. Okay, it will come RLC, right? RLC is common now, so it will be multiplied, so it will come RLC. So guys, if you will take R common, means the equation will become like this: Ls plus 1 plus LC S square is equals to 0. Now take LC common and get in terms of S square plus oh, that's why. See, up to here it is right only. You are taking RLS common, means LCM. So LS will come.
First time will be LS.
LS will come. Here R will come.
R.
Here RL
L.
CS will come.
CS.
So it will be equated to 0. Okay, so you are getting, and this will be S square, I think, right? And I missed something, I think. Oh no, it's everything is correct only. So we are getting this particular thing, and if you will take so RL CS square plus LS plus R is equals to 0. Now take RLC common. If you will take the RLC common, you will get S square plus LS divided by RLC plus R divided by RLC is equals to 0. So what terms you are getting? You are getting like this: S square plus S by RC plus 1 by LC. And in series, what you had got in series? S square plus R by L S plus, here you got 1 by LC only, right? Just wait.
It's L by C.
Oh no, I think we will get LC. So here we did wrong. That's why. See, if we'll take the L common na, so L 1 by LC will come. Okay. 1 by LC will come. Sorry. Here by taking L common, so 1 by LC will come. So not L by C, it will be 1 by LC. So according to that, you have to adjust the parameter. So it will be 1 by LC. 1 by LC. So guys, just let me explain you, because we got the, see, we were having R network, we were having L network, we were having a C network, R network, L network, and C network. And here we are having R network, L network, and C network. So we got the equation here, L di by dt plus IR plus 1 by C integration of I dt. And we got the equation here, V by R plus 1 by L integration of V dt plus C dV by dt is equals to 0. This is my R, this is my L, this is my C. So it will become Ls I of S plus I of S into R plus 1 by Cs into I of S is equals to 0, is equals to 0. It will become V of S by R plus 1 by L of S plus V of S plus Cs V of S is equals to 0. Okay. So if you will take the common, if you will take I of S common, so the equation will be Ls plus R plus 1 by Cs is equals to 0. And solve the circuit and get the result. You will get LCS square plus RCS plus 1 is equals to 0. Now you have to make this as a 1, so that's why you will take common LC. So S square plus RC divided by LC S plus 1 by LC. So that there we did the mistake. So that's why I'm repeating. So we will get S square plus R by L S plus 1 by LC is equals to 0. And in the same way, if we'll do the calculations, we will get S square plus 1 by RC S plus 1 by LC is equals to 0. See, do the calculation and check it. You are getting the result or not. 1 by R plus 1 by LS plus CS is equals to 0. So you will get LS here, you will get R here, and you will get RLC S square here. So take the common, S square plus LS divided by RLC plus R divided by RLC is equals to 0. See, you will get the same result. Means S square, this will get cancel out. S square plus S divided by RC plus 1 by LC. You are getting. So you are getting the result like this. Okay. So see, from if you have a S square plus R by L S plus 1 by LC is equals to 0. From here to here you can move directly. If this is my series network, and I want to get the result for my parallel network, so S square, S term and the constant term will remain same. Means it's a case of a duality. When you are moving from series to parallel, your R will become 1 by R, your L will become C, your C will become L. Okay, so my R will become 1 by R, my L will become C, and my L will become C, and my C will become L. So 1 by LC from here to here. That's why, means there I was not getting one L by C, so I thought I had committed some mistake. So the series network is S square plus R by LS plus 1 by LC is equals to 1. And the oscillations period is 1 by LC only. 1 by LC only. So if you want to find the root of this equation, so what will be the root? S is equals to minus r by L plus minus root under b square. B square is r by L the whole square minus 4ac. Okay, so minus 4 by LC. 4 by LC you will get. Minus 4 by LC divided by 2. So S value you are getting minus R by L plus minus root under, this is B square. So R by 2 L the whole square, and you are getting minus 1 by LC, right? And if you will do here, what you will get? Minus 1 by RC plus minus root under 1 by 2 RC the whole square minus 1 by LC. Okay, so what I told you, for critical damped, how it will be critical damped? When this term is 0. And how this term can be 0? R by 2L the whole square if it is equals to 1 by LC. In this case, how it will be critical damped? When your 1 by 2 RC the whole square is equals to 1 by LC, when it is becoming 0. And this is for critical damp. And for over damped network, when it is R by 2L the whole square if it is greater than 1 by LC. And for here, when you will get 1 by 2 RC the whole square is greater than 1 by LC. This is for over damped. And for under damped, when it will be in imaginary, under damped network, when R by 2L the whole square if it is lesser than 1 by LC, and here it will be R by 2 1 by 2 RC, 1 by 2 RC is lesser than 1 by LC. So this is the case for under damped. You can do the same thing with the equation directly, s square plus 2 zeta omega n s plus omega n the whole square. So in a series network, what is the network? What is the equation for a series network? This is your series network equation. S square plus R by L S plus 1 by LC. So what is omega n value? Omega n value is 1 by root under LC. And what is your 2 zeta omega n value? It is R by L. So what is the value of a zeta? R by 2L root under LC, if it will go that side. So zeta value is nothing but R by 2 root under C by L. So for RLC network, series RLC network, zeta value will be R by 2 root under C by L. And same thing if you want to write for a parallel network, zeta value will be, R will become 1 by R2, and your
C will become L,
and L will become C. And now you need to substitute the value. If this value is greater than 1, if zeta is greater than 1, it is over damped. If zeta is equals to 1, it is critical damped. If zeta is lesser than 1, it is under damped. Is this clear? Guys, is this clear?
Yes, sir.
Okay. So this is the concept. Yeah, zeta value. So zeta value means how to find the zeta value. I hope you understood, right? And guys, you can do one thing, means directly also. You don't need to go for this calculations like that also. If you have R network, L network, C network, always remember this equation, s square plus 2 zeta omega n s plus omega n the whole square. In control system, you will be means familiar to this equation in a control system, because you have to use up lots of times this equation, s square plus 2 zeta omega ns plus omega n the whole square. Directly represent the circuit in the Laplace. R will be R, your L will be Ls, and your C will be 1 by Cs. So in a series, what the equation you will get? R plus Ls plus 1 by Cs. And if you want to go for a parallel network, this will be 1 by R plus L will be Cs
CS
plus 1
plus
by
1 by LS.
okay, that's it. And obtain the and equate with 0 and directly equate with this and get the result of a zeta. Okay, so now come to the next topic, that is AC transient. AC transient. AC transient. So first write it down. We had completed the DC transient. So DC transient and it's a very small topic. It's not a very big topic like DC transient. So DC transient are more severe as compared to the AC transient. Okay. In DC circuit, based on the selection of a circuit parameter, operating frequency and the switching operation, it is possible to obtain the transient free response. Okay.
Sir, can you read that sentence once more?
DC transients are more severe as compared to AC transient. Okay. And I am writing the next sentence. DC transients are more severe as compared to AC transient. And the next sentence is, in DC circuit, based on the selection of circuit parameter in DC circuit, based on the selection of a circuit parameter, operating frequency and the switching operation it is possible to obtain transient free response. What is the transient free response? Okay, so see, if I have a circuit like this, now I have a AC supply. If I am switching this circuit at t is equals to 0, and I have R network, I have L network, and I have a AC parameter V of t. This is my AC parameter. Okay, and this is my L. So V of t it's given as Vm sine omega t plus theta. That means it's having some Vrms value at an angle theta. Okay, so that Vrms will be multiplied with root 2 and we'll get Vm sine omega t plus theta. And your Z will be R plus j omega L, because it's a L network. Okay, and we can write Z mod Z at an angle alpha. and mod z value is root under r square plus omega l the whole square, and alpha value will be tan inverse omega l by r. So for t is greater than 0, for t is greater than 0, now this omega l will not be get short circuited and open circuited as in DC, because I have a frequency here. See this frequency, we cannot do short circuit open circuit because we have a frequency. So v of t v of t is equals to I of r plus L di by dt, because I am getting the circuit closed circuit like this. Okay, so and I am assuming some current is flowing, I current. Some I current is flowing. So guys, this is not very tough. How can you find this? How can you do it? So we have a differential equation, so we can make it in the differential equation only. Di by dt plus r by L into I is equals to v of t by L. I am taking L as a common. So this is your differential equation, and we know that a differential equation can be represented in the form of ordinary differential equation can be represented in the form of complementary function and particular integral, right? Forced response and natural response. We already seen that forced response and the particular integral formula. So guys, as you remember, for complementary function, your force will be 0, means your response, your input response will be 0. So my input is what? My input is voltage, so I have to make my voltage as 0. So I will get di by dt plus r by L into I, and this v of t is 0. Okay, now if you solve this particular ICF, I complementary function, you will get, like earlier we did it in DC circuit, we'll get a e power minus r by L into t. And for particular integral, we have to see for infinite amount of time, and we cannot do short circuit as we were doing in the previous case, in a DC case. Okay, we cannot do the short circuit. We have the circuit like this only, our voltage will be there. So we will do a very simple thing. If I want to find the current for IPI will be V by Z, and V is Vm sine omega t plus theta, and my Z is mod Z at an angle alpha. So how I will get IPI value? IPI value will be Vm by mod Z sine omega t plus theta minus alpha if it will go upper side. What is the value of alpha? Vm by mod Z sine omega t plus theta minus tan inverse omega L by R. So this was the angle what I am getting. So guys, what I am getting, the I of t formula. I of t formula is ICF plus IPI. So this is your transient response, and this is your forced response. This complementary function is for your forced response, and this particular integral for transient response. Okay. Oh, sorry. It is your transient response. This is your transient. Because source is 0 here, no? So it is your transient response because our source is 0. And this is our forced response. Okay. So I of t I am getting ICF value. ICF value what we got? What we got? ICF value A e bar
A
minus
e power minus r t by
right.
l.
And what is my IPI value? V by mod Z sine omega t plus theta minus alpha I am taking. Okay. So because what I of 0 is I before switching I of 0 was 0 because it was not
0.
connected, and our inductor will not allow the sudden change of current. This will be valid for both AC and DC. So at t is equals to 0, this is my 0 and this is A e power minus RT by L plus V by mod Z sine omega t plus theta minus alpha. Okay, so you can find the value of a value you can find easily from here. What you will get the value of a, and you are putting the value, it's a 0, so it is becoming 1. So a value is minus Vm by mod Z sine omega t is also becoming 0 because you are substituting t is equals to 0. So you are getting sine theta minus alpha here, right? Sine theta minus alpha you are getting because t, we are substituting t value is 0. So this will come how much? This will be sine theta minus alpha. This will be sine theta minus alpha. So you got the value of a. Now what will be the overall current equations? I of t will be minus Vm by Z sine theta minus alpha e power minus r by Lt plus Vm by mod Z sine omega t plus theta minus alpha. So this particular is your transient response, right? Transient response A e power minus RT by L. So this particular is your A, and this is your forced response. So transient response is complementary function and forced response is your particular integral. For complementary function, for transient response, we are making the external means input voltage is 0 and we are getting, and for forced response we are applying the voltage and we are checking the current at infinite amount of time. So here because of that frequency we cannot do short circuit and open circuit for a capacitor. So that's why we have a value like this. Now in an exam, if they will ask you, you have a AC circuit, and you want to make it as a transient free response, how it will be possible when this value will be 0, right? In examination, if they are asking, if you have a AC circuit and you want to make the circuit transient free response, how can we make it as a transient free response when this value is 0? How is it possible? Because we have this, we will have this value, we have to make this value as a 0, means we know that sine 0 value is 0. So how can we do this when your theta is equals to theta minus alpha is coming as 0, when your theta value is, and alpha is tan inverse omega L, when you are getting tan inverse omega L by R. So when your theta value is coming at tan inverse omega L by R, the response will be transient free response. Guys, is this clear? Prasanna, is this clear?
Yes, sir.
Okay, so this was the question for means like now we do for the sine function. Okay, sine function. When in the question if it will be a cos function, if you are having a cos function, suppose you are getting a circuit like this. This is RL and this particular is V of t. This is R, this is L. So if it is a cos function, so I of t you are getting, you will get same minus Vm by mod z cos theta minus alpha will come, e power minus RT by L will come. This will be your transient function plus force response will be Vm by mod z cos omega t plus theta minus alpha will come. Now if you want to make the cos function, if the function is in the cos function and if you want to make it a transient free response, so how it will be possible?
Theta minus alpha equal to 90 degree.
Theta minus alpha is equals to 90 degree. Great, because cos 90 degree is 0. So theta minus alpha you want to make it as a 0 degree, so cos theta minus alpha is equals to cos pi by 2. We are taking with respect to radian. Okay, so that's why I have taken pi by 2. So theta minus alpha is equals to pi by 2. So your theta value should be equal to pi by 2 plus alpha. Pi by 2 plus alpha, right? Is this clear, guys? Guys, is this part is clear? Pi by 2 plus alpha means pi by 2 plus tan inverse omega L by R. So be careful. Be careful about these things. Okay, is this cos function or is this sine function? So this was about yeah. Now one thing is one last thing I will tell you. Well, your transient is going to over within 15 minutes. Okay, one last things. Suppose here the delay means the switching time was at 0 second. When in the question, when in the question, when the switching time is, when the switching time, if the switching time is t naught, it is not 0. After some time, particular time, 2 second, 3 second, if they will mention, then the things will get little bit change. RL V of t will be Vm sine omega t plus theta only. Z is R plus j omega L. So it can be written as mod z at an angle alpha. And the value of a mod z is root under R square plus omega square plus L square. And the alpha value is tan inverse omega L by R. So for t greater than 0, V of t is equals to IR plus L di by dt, and you will get di by dt value plus R by L into I is equals to V by L. So this can be written as I of t can be written as I of complementary function plus I of particular integral. So for complementary function we are finding the transient response, and for particular we are finding the force response. So for transient we are making our main voltage as a 0, and for force response we are watching for V at a infinite. Okay, so complementary function we will get. So in this case now you need to write your complementary function, I complementary function, that is a e power minus r by l t it will not be a t, it will be subtracted with minus t naught. Okay, just a small thing. When they will mention some time like 2 second, after 2 second, after 3 second the switch is getting closed. When it will be 0 then it's fine, it will be like a normal. When it will make you some like a delay 2 second, 3 second, then you have to use like this t minus t naught. Okay, and this is your complementary function. For your particular integral ipi you will get v of t by z, that will be same only, vm sine omega t plus theta divided by z at an angle alpha. So that will be the same only. So there will be no vm by z sine omega t plus theta minus alpha. So I of t equation you will get a e power minus r by l t minus t naught plus vm by mod z sine omega t plus theta minus alpha. Now the thing is that now you know the value at t is equals to t naught, not for at t is equals to 0, because we are switching off at t is equals to t naught. So your initial value for means suppose now the current now we have a graph from minus infinite to not for 0, it's exceeded the 0 value. Okay, 0 value, it is exceeded, it's like a 2 second, 3 second. So we cannot put 0 because we don't know about that its conditions over 0, because at t is equals to t naught only this I of t naught minus will be equal to I of t naught plus, means minute change at this will remain same, the current will remain same. That's why we have to put at t is equals to t naught. So at t is equals to t naught the current will be 0, and the current is 0. So you are getting a is equals to, and t is equals to t naught you are substituting, a is equals to a plus vm by mod z, in that you are getting sine omega t naught value plus theta minus alpha. So this value you are getting, so that's why sine omega t naught value is coming, and a value is minus vm by mod z sine omega t naught value plus theta minus alpha. This value you are getting. Okay, now if you will substitute in the main equation I of t, so you are getting minus vm by mod z sine omega t naught plus theta minus alpha e power minus r by l t minus t naught plus vm by mod z sine omega t plus theta minus alpha. Now if anyone will ask you to make it a transient free response, so what will be the transient free response? If you want to make it this value, you cannot change this value, you have to make this value as a 0. So what will be the case? Omega t naught plus theta minus alpha is equals to 0. So your theta value should be equal to alpha minus omega t naught. and alpha value you know, that is tan inverse omega L by R minus omega t naught. And if it was the function for cos, suppose if it was the function for cos, then the value of a theta will be pi by 2 plus tan inverse omega L by R minus omega t naught for cos function. This is for sine function. Is this clear, Prasanna?
Yes, sir.
Understood? So, yeah. So this is for what we had discussed for series RL network. Okay. Now make one note. We'll do by duality. This is for my series. Series we discussed, and for parallel. Okay. So you are having a V of t is equals to Vm sine omega t plus theta at t is equals to 0 we are discussing. Okay. So yeah, let me write like this. This is my series. Okay. This is sources. So what theta you are getting? Theta is equals to tan inverse omega L by R. Here what you will get? Theta is equals to tan inverse omega will be that only, L will become C, and 1 by R will become 1 by R. So you will get R upside, right? By duality. Correct? Omega RC. And for theta value means for making it as a transient free response, theta value should be where t is equals to 0. Now when you are having a V of t is equals to Vm cos omega t plus theta, and theta is t is equals to 0, at t is equals to 0, so theta should be equal to pi by 2 plus alpha, that is tan inverse we discussed previously only, alpha. For parallel network how it will be? Theta is equals to pi by 2 plus tan inverse omega RC. Okay, omega will be omega only, your L will become C, your 1 by R will become R, or R will become 1 by R. So this is the second case. The third case is when V of t is there, Vm sine omega t plus theta, but the switching time is at t is equals to t naught. So what theta you are getting here what you will get in this case? Theta should be equal to theta value should be equal to tan inverse omega L by R minus omega t naught, and in this case theta value should be equal to tan inverse omega RC minus omega t naught. And for fourth case, V of t is equals to Vm sine omega t plus theta at t is equals to t naught. Oh, this will be cos. So theta will be equal to tan inverse omega L by R plus pi by 2 minus omega t naught, and in this case theta will be equal to tan inverse, by duality omega will be omega, L will be C, and 1 by R will be R minus plus pi by 2 minus omega t naught. So don't need to remember the formula if you know the concept. So concept I taught you only. This is for this kind of a circuit, RC circuit, and this is for RL circuit. Guys, is this clear? Guys, is this clear?
Yes, sir.
Okay. If it is clear, then it's fine. Okay, write one question means for solving this transient. And question, it's very simple. The question is, what is the switching instant T naught? The circuit will be free from transient. So question is, at what switching instant T naught the circuit will be free from transient. Free from transient. You have a circuit like this. You have 5 omega value, and this is 0.01 Henry, and this is your V of t value, that is given as Vm sine omega t, and frequency it's given as 50 hertz. So you need to find at what t naught this will be free from transient. So this is the see the things. What is the V of t? Vm sine omega t means your theta value is 0.
0.
And what is the omega value? Omega value is 2 pi f. So omega value is 2 pi into 50. That is omega value is 100 pi. And for making it as for a transient free, and this is the sine source, so theta value should be equal to alpha. You remember na, or you forget? Theta value will be equal to alpha
Theta plus alpha equal to 0, we have to make it.
alpha minus omega t naught, right? So theta is equals to alpha value was tan inverse
That was
omega L by R
omega L by R.
minus omega t naught, and you need to find the value of a t naught only, and this value is 0. So you will get what? Omega t naught is equals to tan inverse omega L by R, right? So omega t naught tan inverse omega value is 100 pi into L value in this question it's given as 0.01, and R value is 5 ohm. So you are getting T naught value, that is omega value is 100 pi I am writing, and that tan inverse is pi by 5. So it is in radian. So calculate the value and get the result. T naught value is 1 by 100 pi tan inverse pi by 5. So T naught value will come how much? 1 divided by 100 into pi. What is the value of a tan inverse pi by 5? It is in radian. So be careful. You will get 0.56 divided by 100 divided by pi. So you are getting T naught value is 1.785 millisecond. So if your transient response, if you will switch off the circuit at t is equals to 1.78 second, then this circuit will be free from transient. Is this clear, Prasanna? Understood what we did it, or any doubt?
Clear.
Clear. Okay. Okay. So it's good. So now means like we have to complete. We had completed approximately 330 pages. So from the notes and all. So we need to
So
cover.
tan inverse
Yeah.
180 by 5 is 88.4.
So you need to, when you are doing like this now. So then you need to convert this as in a degree. 100 pi.
Just in degree mode only, I'm getting a 88.
So how much you are getting tan inverse pi by 8?
88.4.
88.4. And if you will divide it by 100 pi na, you will not get the answer, because this is the omega is given in radian, right?
Yeah, in radiant I'm getting
Yeah.
1.5.
So that, see what I am telling. Just see, if you want to convert that omega t naught tan inverse, and you are getting you are converting it into a degree mode, so you will get the different answer. So always be careful, because this omega is in radian, right?
Yes, sir.
So degree cannot be divided by radian. So radian by radian will get cancelled out, and you will get in the second, radian per second. So it is in radian.
Yeah, okay.
Okay, radian per second. This omega value is radian per second.
So we have to take in radiant only in tan
Radian.
inverse. Yeah.
Okay. So you will get. So we had completed like 330 pages we had completed, and only 50 pages remaining. So this will be cover, I think, within 2-3 days. 2-3 days, 2-3 or 4 days, the network will be over. Okay. So tomorrow we'll see some applications of a Laplace transform. Okay. Applications of a Laplace transform is there. It will hardly take half an hour for that. Then we can move for resonance circuit. Resonance is going to be over tomorrow itself. Resonance is going to be over, and parallel resonance and series resonance, yeah. And tank circuit resonance circuit, yeah. Okay. Dynamic impedance, okay. Then we'll move to the last chapter of this network, that is graph theory. So I think 4 classes in a 4 classes your network will be over. Then we'll see 3 classes for completely 3 class will be for your answer solution of the workbook and all. So you are practicing, Prasanna, from a gate book. Have you got the gate book? Means have you purchased the gate book? Prasanna, I am asking to you, have you purchased it or not?
Sir, I got it from the library. Sir.
But you should buy, yaar. You means like if you'll buy, it will be your only. Na, you can just buy it. Why you are means saving means.
Sir, it is with me only, sir.
Okay, then fine. Just solve it then. Means the questions, if you can solve. If you are seeing the network means now solve all the network questions. Then only you will be able to command the network. Okay. It's required lots of practice. Okay, Prasanna, we will meet tomorrow.
Sir, like, can I ask you a question, sir?
Yeah, sure.
It's related to the motors. In synchronous motor, we have to give AC to the armature winding and the DC to the field winding, right?
Yes.
Why we give a DC supply to the separate field winding, sir?
See, in a synchronous motor, na, if we are giving a DC supply na to field winding, Why so? Because if you will give the AC, it will get pulsating in nature, right? it
Yes, sir.
it will get pulsating in nature, so the device will not, means your motor means like a armature winding and field winding, it will get pulsating. Because of that there will be a some harmonics will develop. Okay,
Yeah.
so to tackle out that kind of a harmonics, we are making like a electromagnetic, we are providing our armature winding means as a electromagnetic. Okay,
Yeah.
so we'll discuss now, we'll discuss these things very perfectly when we'll because it's a, this concept is a very, it's require a vast knowledge. Okay, so
Yes.
you will see in an induction motor why we are doing squeeing. Okay, cogging is there, the hunting is there, lots of things is there, so we will see these things. Okay.
Okay. Sir.
Okay. So right now you are studying means synchronous motor in a class.
Yeah, drives is going on, sir.
Okay, drive is
Electrical
going,
drives.
electrical driving is going on. Okay. Okay, bye, good night.
Yeah, good night, sir.